This video goes over 10.3 and 10.6 to get you ready for the quiz. There's a couple of objectives here. First, we're going to talk about Eulers Formula, v minus e plus f equals 2. And we'll extend the midpoint and distance formulas that we learned earlier in the year to 3 dimensions. Then we'll practice finding the value of some different figures. Eulers Formula says that for any polyhedron, which is a solid figure with many plane faces, if you take the number of v vertices, you subtract the number of e edges, and you add together f the number of faces, you will always get 2. So in this first example, we see 1, 2, 3, 4 for the vertices. And if you count up the edges, we see 1, 2, 3, 4, 5, 6 edges. And if you look at the faces, there's 1 in the bottom, 2, 3, and then the 4th one there in the back. 4 faces. And this checks out because 2 is equal to 2. And same thing over here, 10 minus 15 plus 7 is also equal to 2. So for 2, 3, and 4, I'm going to count the vertices, edges, and faces, and it can be kind of tricky in 3 dimensions when you're looking at a figure that's drawn in 2 dimensions, so that's why this formula can be helpful, or at least one of the reasons. So the vertices, 6 in the first one, 6 in the second one, and 10 in this third figure. So we'll write the formula at the bottom, and we'll go to edges next. I counted 9, 10, 20, and finally faces. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When we're counting faces, that's probably the hardest one. Just think there's 1 on either side, and then there's 1, 2, 3. Here there's a base, and then there's 1, 2, 3, 4, 5. Here there's 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. So in each of these cases, we get 2, which is what we want. The distance and midpoint formulas are the exact same as they were before, where we took x2 minus x1 plus y2 minus y1, both of these squared and underneath a radical. But now we're adding the third dimension z. And a same thing for the midpoint. We used to take the average of the x's and the average of the y's, and now we're adding the averages of the z's. The reason why we square the difference is to cancel out the negatives. And our distance will always be written as a length, where our midpoint will be written as a coordinate. So for number 11, this is our formula, and we can plug in 5 minus 0 squared plus 9 minus 0 squared plus 10 minus 0 squared plus, no more pluses there. So this becomes 25 plus 81 plus 100. When you take the square root of 206, you get 14.3527, so on and so forth. They want you to round to the nearest tenth, so this becomes 14.4. While I have the distance formula there, I might as well do the distance for number 12, and then the distance for number 13 also. So 7 minus 0 gives me 7 squared. Here I'm going to take 0 minus 3 squared, so that's going to be negative 3 squared. And this last one, I'm going to take 14 minus 8, so that's going to be 6 squared. So if I square those, add them together, take the square root of their sum, and I round it to the nearest tenth, I get 9.7. For 13, second minus the first, so 9 minus 4 is 5 squared. 12 minus 6 is 6 squared. 15 minus 10 is 5 squared. So 25 plus 36 plus 25 gives me 86. To the nearest tenth, I'm looking at 9.3. Next up for midpoint, the formula changes, but the same general approach. We can plug in the 2 x coordinates, and I average them, so I get 2.5. The 2 y coordinates, I average them, so I get 4.5. And then the 2 z coordinates, and I average them, and I get 5, and that's my midpoint. For 12, the average of 0 and 7 is 3.5. The average of 3 and 0 is 1.5. And the average of 8 and 14 is 11. There's my midpoint. For 13, the average of 9 and 4 is 6.5. The average of 6 and 12 is 9. And the average of 10 and 15 is 12.5. There's my midpoint. That brings me to volume, which if you never really understood what volume actually means, the volume of a three-dimensional figure is the number of non-overlapping unit cubes of a given size that will exactly fill the interior. So this is sort of like a Rubik's Cube, and how many of those little individual cubes will you see to make this cube? Well, the answer is 27 if you bother to count them. And one way to calculate that is to take 3 times 3 times 3. This distance, and this distance. So that works for these prisms, like 10 by 12 by 8. You just take length times width times height to figure out the volume. And it's the same thing with a cube. You could call it length, width, and height, but since they're all the same side length, you can just say s cubed instead. When we talk about the volume of a cylinder, for example, we're just going to take the area of the base and multiply it by the height. So that changes a little bit in terms of which figure we're looking at. Here we're looking just exclusively at cylinders, so remember that the area of the circle is the pi r squared. That's where this comes from down here. That's the area of the base, pi r squared. And we're going to multiply that by the height. They're going to tell us to give answers in terms of pi and round to the nearest tenth, so both. So 9 times 4 is 36, that's the area of the base, and our height, notice the 90-degree angle here, is 36. So our volume is 216 centimeters cubed. We just took 6 times 4 times 9, and that's our unit for volume. For a cube with edge length of 8, we could either say 8 times 8 times 8, or simply 8 cubed. They're going to be the same thing. Our answer would be 512 feet cubed. So the ice cream cake takes a couple steps. The first one is to figure out the volume of the cake in feet. Then we're going to convert the units. Since we want to cancel out feet cubed, I'm going to put that on the bottom, 0.134 feet cubed. And that equals 1 gallon. And then they want to know about the weight given a certain density. So I'm going to put 1 gallon on the bottom so they cancel out. And on top, I'm going to put the 4.73 pounds. I'm going to put lbs for pounds. So if you multiply across the bottom and divide by the product of the bottom, and I just noticed they asked you to estimate the volume in gallons somewhere along the way, and then the weight of the cake. So this many gallons and this many pounds. I just rounded to the nearest whole number there. So for these, we have to find the area of the base and multiply it by the height. So we're given these values. Since the diameter is 12, the distance all the way across, we know that the radius is half of that. This is the formula, pi r squared times height. We plug in for r, and they told us to give the answer in terms of pi and round to the nearest tenth. Since it was 1130.97, we round up to 1131. Here on the right, we use the same formula, pi r squared times h. They directly gave us the radius this time. So we plug that in, 45 pi, or 141.4 feet cubed.